Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome to the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. Everyone, hey, welcome into the program. So today on the show, in the second part of the program, we will have computer and technology news, where we cover all the latest tech news, tech stories, tech products, anything that catches our attention. It's a full-time job, and hey, we do it so that you don't have to. And there's a lot of there's a lot of fun stories out there, and unfortunately, a lot of it is talking about the recent storms that are happening in Texas and other parts of the country. The winter storm is just wreaking havoc across a lot of the United States. And yeah, we hope that you're all staying warm and you're all you're all happy and ready for today's program. So before we get started though, and by the way, in the first part of the show, we will of course have a guest, and our guest is none other than Edgewater Wireless. They are a very innovative company when it comes to the research and development side. And also they have a couple products all about spectrum slicing, spectrum splitting, and just, making wireless better, which, as we were talking about before the show, I think that a lot of us have found a new appreciation for being connected while at home or businesses or just wireless. It's, the ability to work from anywhere, be anywhere is super important. So before we get to that though, computeramerica.com, that's where you'll find everything, including past shows, future shows, all the shows. There you'll find show notes, video archives, the podcast, which is simply our radio show redistributed as a podcast. In case you miss it, you can time shift us, all that good stuff. Links to social media, and for the month of February, over on the right, you can of course see the giveaway that we're doing for our 30th anniversary. That's right. Computer America turned 30 at the beginning of February, 30 years on the air from humble beginnings in the basement of Palm Beach Atlantic University. That's right. That's when Craig started back in 1991, flew in guest, and that was really we have evolved ever since we were picked up by WJNO and then distributed across the country. And 30 years later, the rest is history. And to thank you, we want to give away to as many of our listeners as possible. And it's completely free to sign up. There are daily entries, and you can win hundreds of dollars worth of prizes. So again, thank you so much, and looking forward to another 30 years. Now, with all that being said, why don't we go ahead, bring in our guest, get the conversation going, and we can talk about, something that a lot of you may be wondering. It's 2021. Why the heck is my wireless so bad? What's next? What's new? What's different? And I think that our guest is going to be able to answer that very succinctly. So joining us today is Mr. Andrew Scoffel. He is the CEO of Edgewater Wireless. And Andrew, I just want to say welcome back to the program. How you doing?
Great. Well, thanks very much for having me, Ben.
Perfect. So, I think a good place to start would be just a little bit about yourself and about Edgewater Wireless, and also I think we can kind of lead off with this because our audience may remember the last time you were a guest was when COVID was like a word just kind of being thrown around here and there, and things were starting to shut down in the very beginning of March. And I think mid-March was when a lot of the quarantines and shutdowns started to begin. So I wanted to ask, again, your background, Edgewater Wireless background, when was it founded, what's its mission, and then how you been?
Ben, it's been an interesting year since we last
For sure.
Spoke. My name is Andrew Skafel, and I'm the president and CEO of Edgewater Wireless. And we're a disruptive innovator in wireless communications. We really focus on something called Wi-Fi spectrum slicing. So it's a disruptive approach to Wi-Fi that really takes communications to the next level. We're slicing up the spectrum and allowing you to do more with the spectrum that's available.
And we're going to get into some of the the basics with that concept as well. But and why don't we just go ahead and get into that? So when you say that spectrum, I've been hearing a lot about a lot of different kinds of spectrums, and I think we just had a guest on the other day talking about the sub 1G spectrum as well, which or the 1 gigahertz spectrum, which is an entirely kind of long range additional kind of way to it. So whenever we hear the word spectrum, could you break that down to a better analogy that our guests or our audience may may be able to relate to? What is a spectrum, and why does it need splitting up even more than what we currently have?
So its spectrum is, for lack of a better word, it's the air. And it gets divided up into different bands or different lanes, which we use for different types of communications. Wi-Fi has typically been done in the 2.4 and the 5 gigahertz band. Mm-hmm. And there's been some recent developments now in the 6 gigahertz band. Now, each of those bands is a limited space, and it's a scarce resource. Now, traditionally, the approach to Wi-Fi has been, hey, we'll turn on a radio, connect your single device, and away you go. Great approach. And it's led to almost 13 billion devices connected to Wi-Fi.
That's a few.
And back when Wi-Fi first came out, I'm sure no one imagined it would be this wildly successful. Now, when you pack all of those devices into the spectrum, it's like putting all sorts of cars on a single lane road. Right, the congestion just gets so bad that you can't move, or there's a lot of collisions. Well, mm-hmm. that happens in Wi-Fi and that shared spectrum. So because there's a limited resource in spectrum, it's incumbent on service providers, operators, and in Wi-Fi's case, could be individuals, to use that spectrum more efficiently and reduce those collisions, because that's really what causes poor Wi-Fi performance. All that jittering video for those listeners doing online schooling, that's really gets disrupted when there's collisions or contention taking place on those single lanes. So what we've done at Edgewater Wireless is we've said, well, how do you deal with traffic congestion? And we've applied a very simple concept to Wi-Fi, and we've developed the equivalent of a multi-lane highway for Wi-Fi.
Gotcha. Yeah, and of course that multi-lane highway, we can talk a little bit more about that, because some of our other guests that we've had on the show, like let's take Netgear, or Cisco, or some of these other companies that make the routers, the hardware. Their approach to this problem hasn't been so much to, and of course you can have multiple radio antennas. So instead of kind of better utilizing the highways that you have, they just built more highways, I guess, is a way to kind of think about it. They built more roads. And I think that, so, and the other way that they're approaching this is from a software side, where I guess they're better utilizing the limited resources, like you were saying, that they have, and using software to to break up the packets. Essentially a printer doesn't need the priority that a streaming video might need and things like that. So for Edgewater Wireless, your approach to this, is this software, hardware, or is this something completely different than, I guess, kind of either one of those when it comes to this problem?
So, our approach is really dramatically different from something like a Cisco or Netgear. For us, those are potential customers of our approach. And at Edgewater, we've taken an approach that says, things like software and certain techniques like MU-MIMO, for example, or multi-user MIMO. These techniques are all really about improving the efficiency of a single lane. Now, all of those techniques get even better when you run them on multiple lanes and you coordinate those multiple lanes. So we're really the only folks that have approached the problem from what's called the PHY layer, or the physical layer. So physically adding radio capacity and reducing interference, because that's really where the problem lies. And the reason why you typically see only a single radio that operates in 2.4, because they can't deal with the interference of adding more radios. Similarly, in the 5 gigahertz spectrum, most access points have a single radio. Some of the newer, more expensive ones have 2 radios, but they have to park them at opposite ends of the spectrum because of the interference issue. Now, what we do is allow you to stick those multiple lanes within the same band. So it's a very different approach, complementary to some of the things you've mentioned, but again, the next step in the evolution. It's one of those things that when we look at technology holistically, the shift from a single channel to multi-channel is really where performance has stepped up, and it's been proven to work in things like phone lines, right? The traditional phone line, where we went from a plain old telephone line to what's called DSL, or digital subscriber line. Well, that's a multi-channel approach on a wire. The same with DOCSIS, and that's how we get the big step up in performance. So something like MU-MIMO, you might get a few percentage points performance improvement if all of your devices support that. What we're talking about is 10 times, 20 times, 30 times better performance. So it's it's a significant step up.
So, and that begs the question that, there's a lot of companies out there that would, I'm sure, love to utilize something like this. And like you said, your potential customers, they haven't been sitting around, kind of doing nothing. They've been trying to perfect, kind of like you said, the multi-input, multi-output, multiple antennas, multiple radios, so on and so forth. How did you come up with this this multiple approach, and what makes your approach so much different than, I guess, what other companies have been traditionally trying to accomplish?
Well, I think our approach, the Edgewater approach is something that's taken a whole lot of smart people a significant amount of time to do. What folks like to say is they don't put the smart people on TV. The smart people are all working in the back room, making it all happen. So we've been quite fortunate to have a lot of smart people really working on the approach, and frankly, when it was first developed, it was really ahead of the market, right? Solving a problem that wasn't there. But as the number of devices has increased exponentially, and now you're seeing your average home with 10, 20, 30, sometimes 50, 60 devices. That's where the problem becomes so acute. You have a limited amount of spectrum, and if you want to provide decent performance, you have to slice it up to allow everyone to operate.
So, and you probably have better data on this than I definitely do. But when you do this spectrum slicing, obviously that means that you get the much better throughput. And I'm wondering if the bottleneck that people might experience is strictly from the amount of data that can be put through the air, and how much, if any, is there a bottleneck for the, let's say, the router or whatever's handling the traffic on either end of the wireless side? Is there any? With your technology, you're saying 10 to 20 times the data throughput. Could that lead to bottlenecks elsewhere that then Edgewater Wireless would have to kind of overcome as well?
Since since the start of the global pandemic, we've really been starting to look at applications within the home. And when I take, for example, my home, we have gigabit internet to the house. Mm-hmm. Right. So right to my basement and to the router there. Now, the biggest issue isn't so much getting that data throughput to the router typically in the basement of your house. It's really about getting that throughput and that performance out to the devices within the home. So it's even less than the last mile is what we call it in the industry. And so, what we've seen in recent studies is the majority of devices within the home are performing well below the performance numbers promised in Wi-Fi as a whole. Right, when you walk into your favorite retailer, like and you go and you pick up an access point off the shelf, in mm-hmm. big gold letters on the side, it'll say gigabit throughput. It'll say these extraordinarily fast speeds. Well, by the time you get that to your house, you turn it on in the basement, you've got all your devices connected. You're lucky to get 100, maybe 200 megabits through that thing. So a small fraction. And so, really what the problem is from that air interface or that physical connection. And we've seen a very solid correlation between the number of devices, whether that's your iPad or your laptop or your gaming station or your TV connected to the access point, and the phi rate, or the maximum possible throughput, it declines rapidly. So more devices means that capability of delivering higher speed declines. So what we see is the overall data that gets passed through the access point actually declines instead of increases. You'd think if you put more devices on it, the mm-hmm. data throughput would go up. But what happens is very much like the traffic jam that I described earlier. All of the devices are contending for airtime. And so the overall data going through declines. And the only way you fix that is to fix the physical mechanism, or the phi layer, which is what we do.
Yeah, no, it makes perfect sense. Things aren't essentially waiting in traffic to get through to, get their signal through. Everything just kind of flows much faster. Makes perfect sense. And I guess at some point that would also mean that these devices would have to send less redundant packages or packets and things like that. So, hey, just everything kind of speeds up just that much more. My next question, and this is something I don't recall asking you in our past interviews, but I'm actually pretty curious, is that there are subtle ways that interference happens. And I'm wondering with spectrum slicing, because, these, much more narrow, maybe they would be less prone to interference or more prone to interference. And of course, this would be on essentially a device by device basis. It wouldn't be, just that your computer would experience more and your TV would experience less. And I could take a couple educated guesses on what's going to happen, but talk about interference when you introduce spectrum slicing. Does that go down, go up, reduce? What happens? The ability to deal with interference is much better with spectrum slicing. Now, if you look at the traditional approach to Wi-Fi, so the legacy single channel approach, you have one channel or one lane. Mm-hmm.
And if there's interference in that lane, it affects everyone. Now, because we're using multiple channels and we have a much wider view of the spectrum, it allows us to mitigate those sources of interference much better. Now, there's one other thing that's pretty exciting about our approach is because we're supporting multiple channels, we actually use a wide view of the spectrum, or something called a wideband RF front end. Well, what that means is instead of looking at a tiny bit of the spectrum in the channel that you're on, we're actually looking at big swaths of the spectrum, and we can proactively see what's happening in the air. So we can identify sources of interference and identify ways to mitigate that. So that's, there's a few mechanisms that we employ that allow us to get around the interference a lot better than a single channel.
I'm wondering, and you probably have already thought about this, if you have all these, additional lanes that you can utilize, maybe when I say redundancy, maybe sending two at a time, hoping that one gets through, or, kind of sending them one after another. I'm sure that there's some world where someone who wants a rock steady connection could utilize multiple, I guess, kind of these lanes with the same device. And then I guess it would be up to the software to say, all right, we have two of these from the same sources, throw one out, we got one, we're good. Is something like that possible, or is that something that you looked into?
That's a brilliant idea. One of the things that we've done through our co-innovation partnership with Cable Labs is we've developed a new standard called dual channel Wi-Fi. And essentially, dual channel Wi-Fi is allowing you to create redundant paths. It's taking a traditional Wi-Fi connection, right, which is bidirectional, and it's setting up data-only downlink channels, right, that are uncontended. So if you were to have a high-definition television connection, that downlink-only channel is the best way to get uncontended data there. Now, the way the standard has been written is you can have multiple downlink channels. So it's called dual channel Wi-Fi, but you could use 1, 2, 3, 4, as many download channels as you need to deliver that performance. So it gives that redundancy that you're talking about and delivers better performance. And that's really part and parcel about some of the benefits that spectrum slicing delivers to end users and to service providers alike.
Yeah, and I think about all the applications because, let's say in a studio like ours, everything is wired, and it was a pain in the neck to kind of set it up like that. But if you could have the reliability of a wired connection over a wireless connection, I kind of fail to see how people would ever, kind of go with wired again. Having that steady connection is just super important for certain applications. I'm sure that it's overkill for a lot of things, like let's say printers, but at the same time, it's I'm glad that you have applied it to not just getting more devices, but also getting certain devices better connected as well.
That's right. Yeah.
Perfect. So yeah, and of course, with all that being said, we can pivot the conversation a little bit. And by the way, I was just because I didn't get a chance to see the consortium out there at CES this year, but I'm always curious about Wi-Fi. We've been talking a little bit about Wi-Fi 6. That would be the AX standard, which I believe the difference between AC and AX was simply that multi-user, multi-output, or I'm sorry, multi-input, multi-output, essentially getting more devices onto a Wi-Fi network. That was the real thrust of Wi-Fi 6. Because let's face it, we have, like you said, in a home setting, phones, computers, tablets, light switches, light bulbs, printer, there's so many different devices that get put onto a Wi-Fi network, and, we're kind of handling that. I was looking up standards for Wi-Fi 7, and when you see some of the improvements that Wi-Fi 7 is expected to bring, they're saying now in 2024, so we're still a couple years off from this being standard, but some of the improvements for Wi-Fi 7, unfortunately, not yet. I don't see, kind of spectrum slicing included in the spec sheet, but here's to hoping. when you see the increases, like in some cases they're saying that Wi-Fi 6 and 6E, you have 2.4 or 5 gigahertz, Wi-Fi 6E is 6 gigahertz. Now Wi-Fi 7 is looking at 1 to 7.25 gigahertz. These improvements in utilizing different spectrum bands, you see that as just, that's great and that's a needed evolution of the technology, but you also see that as I guess your technology applies to every new band that they kind of decide to start using.
That's right. Our approach is applicable through whatever Wi-Fi band that gets implemented, and for that matter, through other wireless technologies like 5G, for example. And the convergence between Wi-Fi and 5G is happening today. Now, it's really exciting to see the moves by the FCC in the US to free up some of the 6 gigahertz spectrum. Pretty exciting stuff. It adds a number of channels. EU looks to be following suit. In the EU, it adds 3 channels. So each of those implementations could benefit greatly from spectrum slicing. Right? You're simply adding. The question is, could you benefit from more capacity? And the answer is always yes. Right? That's.
Yeah, and I'm really excited for what's going to happen with all that. Although it's still a little bit far off, and I'm really afraid that the 6 gigahertz in particular suffers even more from what the 5 gigahertz did, where even just like a simple wall would have that interference. It like in some cases, I'm thinking that the 6 gig. Wi-Fi is going to be like line of sight only. Like you're only going to be able to do things that are.
Well, that's right. It goes back to your physics class, right? The propagation of 6 gigahertz, will be very, very small, and a lot of the regulation, is limiting the power levels that you can use as well, which sort of exacerbates the distance and the propagation problem.
Right.
The best propagation in the space is still in the 2.4 gigahertz spectrum, and it is so widely used.
Right. And, but of course, one of the unfortunate side effects is that your microwave also uses the same bandwidth. So if you ever wonder why you're sitting in the kitchen and you're using your phone and then the connection gets really bad when you're microwaving something, there you go. So with all that being said, we're also seeing a rise, and you mentioned before the show that you wanted to talk a little bit about this. We've been talking about Wi-Fi, and this is, again, super important in people's homes, but we're seeing arenas start to open back up, and a lot of places have gone through taking advantage of the coronavirus in that with less traffic, they can do some of these major renovations that they were kind of putting off. And I think one of the renovations, a lot of stadiums, public spaces, things like that, I hope that they took advantage of was the ability to put in new 5G towers and, transmission points, essentially ways that you can get 5G in more places. Ladies and gentlemen, we did a whole subject on 5G and about the safety of it and that whole thing. Not going to talk anything about that there. 5G, completely safe, but 5G also, I've heard some situations where, Andrew, that let's say in a particular arena, and don't get me wrong, basketball, football arena, stadiums, things like that, they're huge, they're big buildings, but there have been situations where, due to that propagation issue, 5G in particular, they had one set up at the entrance when people are waiting there, get ready to file into the venue, but on the other side of the venue, like of the same building, they did not have 5G connectivity because there just wasn't, the distance to get, the distance was just too far. So 5G versus Wi-Fi, is there any interplay there? Are you excited for what's happening with 5G? Because we're also seeing, to a lesser extent, the advent of, I guess kind of like 5G routers where you can actually purchase them from your cell carriers and actually transmit your own 5G in your own home. How do you feel about 5G? Is there any interplay with spectrum slicing there? And
There's, what we've seen in our work with some of the global service providers and our work with the Wireless Broadband Alliance, for example, is that a lot of there is a strong interplay between 5G and Wi-Fi. Wi-Fi, with the 13 billion devices, has established itself as the primary communication mechanism for within the home. And it's very complementary to a lot of the 5G cellular networks. For the stadium that you were mentioning, makes a whole lot of sense to have cellular technologies used outside and technologies like Wi-Fi and cellular working jointly inside. So there is a very strong alignment there, and with spectrum utilization and efficiency, slicing that spectrum so you can support more devices and more users from a single radio is the sensible thing to do. It's really the only way that you can support the vast number of devices that are forecasted to be in the 5G space. And what we'll see are the larger operators blending the two technologies together and doing things where you're seamlessly and securely handed over between various networks. And as a user, you won't know whether you're on the 1900 megahertz band or the 2.4 megahertz band, because at the end of the day, it really doesn't matter. I just want to get service wherever I am.
So I'm going to say that you're wrong there for one simple fact, and it's because marketers, for some reason, love new standards. And,
That's right.
Much like we saw 5G, 5GE, things like that wasn't even actually 5G. Marketers love to kind of push this idea of like the next level of Wi-Fi as a selling point. So, marketers will make sure that you are wrong on that one. And everyone's going to know when you're using the latest and greatest kind of thing. But from a consumer standpoint, you're absolutely right. As long as everything works, what do you care how it works? And that's something that I can totally see the wireless industry just becoming to the point where, if everything loads instantly and you can send and receive messages and videos and things like that, what does it matter what technology you're actually using? So makes perfect sense. So with that being said, I also want to talk about, because we do have a monthly Linux segment here on the show, and we always like to applaud free and open source. And open source, as we have talked about there, just for anyone out there who tunes out for our Linux shows, the real benefit of open source is not that it's free as in speech versus free as in beer, which is kind of what they always say. It's not so much that that you have made this open source so that you don't earn any money. It's you made this open source so that others can quickly and easily adapt and innovate using your technology. So what was your decision what was your decision process to make this open source?
It was twofold. I think we very clearly understand what we do best. And that's spectrum slicing. So our core focus is the spectrum utilization. Now, in order to get our silicon or our spectrum slicing approach more widely adopted, moving down the path of using Linux is the most sensible possible thing that you can do. Right? There's a massive open source community that brings so much value to the space. So it really helps drive growth of our technology and really helps get it out in front of as many people as possible.
And of course, that the next question we have here in our notes is about the licensing and being able to do this. Obviously, you would work closely with some of the larger providers and partners out there to get this technology kind of integrated. But when you have when you do open source, anyone can kind of pick it up and adopt it and run with it. How will this be available to Linux users to use in anything that they kind of set up? And what about the hardware manufacturers that we mentioned before that this would integrate so seamlessly with?
Yeah, so our approach for licensing is very much driven and directed towards silicon providers, right? The major silicon providers are ones that could benefit greatly from spectrum slicing. So imagine if your Intel, Broadcom, Qualcomm, etc., could implement features that were actually differentiated from their competition and deliver better service to us as the end users. So that's one way that it takes place. Now, in terms of the developer world and the Linux world, we also have development kits, right? Mm-hmm. Which are a ready way to develop access points and devices powered by our silicon. And that's really based on some of the OpenWRT and the Linux developments that are there. And it gives developers a playground to really get to know our technology and drive that forward as well.
Gotcha. Yeah, and a couple of days ago we had another guest that was set up by by our friend Nelson there. That we were talking about kind of smart labels where they could be updated wirelessly to display different things such as price changes or different kinds of stock and things like that. And during our conversation, we actually brought up Edgewater Wireless because when you have in some cases. If you were to implement their solution into something, let's say like a Walmart, you could have, in some cases, how many labels are in a Walmart grocery store, and having to update all those and have all those communicate wirelessly, it would be very, I think to someone like them, they were talking about in some situations, they set up 4 different units. And I'm sure for an environment like Walmart, it would be something much, much more, maybe even upwards 20 or 30 different devices to handle all of that traffic. Do you think that solutions that we're seeing now, Wi-Fi 6, again, helped pave the way for a lot more devices, especially in the home and smart home arena, to communicate? Do you think that something like yours could help hardware, kind of the people making the hardware, to have to use less units to handle all the traffic for what they're trying to do? Because again, multiple units to handle so many different channels, that seems like your kind of thing.
That's it. That's exactly it. For a large enterprise deployment, we typically quote less than half the number of devices that are needed with traditional Wi-Fi, and that has 2 benefits. Right, from a capital expenditure perspective, for someone like a Walmart or someone like a large retailer, mm-hmm. There's the cost of the access point. Plus, there's the cost of a cable pull, and pulling cable in a retail environment or a large enterprise environment could be $1,000 a cable pull. So there's a significant cost reduction there. Now, from a performance perspective, simply reducing the number of access points reduces interference. Right? So there's less noise and better performance overall. So spectrum slicing offers a really solid value proposition to the enterprise space, especially to these places that are going fully wireless now.
Right. And by the way, this multi-spectrum slicing, this Wi-Fi spectrum slicing that you have, by the way, looking at some of the material, and I'm not sure if you need to update it eventually or not, but Wi-Fi kind of pulled the rug out from underneath you guys to say they switched from, the 802.11, BGN, AC, X, whatever, that kind of naming, and switched it over to Wi-Fi 6.7, 4, 5, 6, 7. A lot of your material says Wi-Fi 3. And unfortunately, Wi-Fi 6 just sounds like a more advanced version of Wi-Fi 3. Is there any change in marketing you're going to have to do? Because they changed that just last year.
If you clearly we were making our mark on the industry, right? If they steal our branding, for lack of a better word. And
it was much simpler. Yeah.
It is. It is much simpler, but I still don't know what the heck Wi-Fi 6 means. There is absolutely no logic to that selection. At least with our old branding of Wi-Fi 3, it was around 3 channels.
Yeah.
Very clearly.
Wi-Fi 6, now, I believe, and sorry to cut you off there. I'm just saying that Wi-Fi 6, I think, was the 6th iteration, of replacing AX. And of course, I'm with you. I was totally comfortable with the BGN, AC, all that kind of thing. But yeah, they wanted to dumb it down, and unfortunately, they actually leapfrogged you. So, yeah.
That's right. And so now we've adopted spectrum slicing. Which is a great evolution of our branding, because that's what we do. And it's not limited to a specific number of channels, like 6 or 7 are limited. And so spectrum slicing is a much broader approach that has much more meaning. And our silicon product is called MCSR, or multi-channel single radio. And there's a number of different variants within that product naming convention.
Gotcha. Yeah, and I know that since the first time that you joined us, the new Wi-Fi naming scheme had not been implemented. So Wi-Fi 3 was different than all these others.
That's right. That's right.
Yeah, they.
It's a classic. It's a classic attempt by the incumbents to quell the scrappy upstart. Didn't work.
There you go. Yeah. Just a little bit more, and actually, honestly, a little bit more on the nose branding. So I think you got the best one there. So with that being said, we saw that you have your own router that people can actually purchase from you, and I'm sure it's a proof of concept, but it's an actual physical product, which is great. It's not just you do have a white paper, but it's not just a white paper. You do have a product that people can actually see this in action with. With that being said, if it were to be implemented into a lot of other devices, would I have to go out and throw out my current router to get one of yours, or is this a software solution that things can be updated kind of wirelessly and existing routers are good to go? In your mind, imagine snap my fingers and everything is now multi-spectrum slicing. How long would it take to implement this? Is this a replacement of hardware, or is this overnight?
This is a hardware solution, that's based on a new chipset within the access point. So that's where that's what would need to be done. So we need to replace your router in your home.
Gotcha. Yeah, and of course, there's nothing wrong with that, because I think a lot of people, unless your name is fun fact, Andrew, I never say my current internet provider because I talk so much smack about them, I could actually get sued. But unless you're my current internet provider who's still using 12-year-old equipment in my home, so I could go on about all the. Okay, this is a complete aside. Let me just tell you that they upgraded us to 400 megabits per second, connection, and which is good. I'm not really complaining about that. The router, the modem that they sent us physically could not handle the traffic that they were sending us, and was causing our entire network to crumble because that was the latest modem that they had, and I had to go out and purchase my own modem, and then I had to pay for that modem that was sitting in a box collecting dust for 2 years, because I could not just return it and not pay it. I had to actually keep paying for it, even though it would have made my entire network crash. Anyways, that's a whole nother issue. I guess the only takeaway we can take from that, Andrew, is that speeds are getting up there. Speeds are getting better. Connectivity, right, I think, seems to be the real for so many applications. Connectivity and stability seems to be where it's really lacking, and I believe that's my best way to turn my complaints into something of a coherent statement concerning Edgewater. So, with that being said, So if, and by the way, speaking of white papers, you guys have not been, sitting around. You've been, if you go over to the website, again, edgewaterwireless.com, you can see a couple of different products that you have. And of course, case studies that you are providing as well. Talk about some, what you guys have been up to over the past year, because, this, at this point, is it refining the technology and the patents and the products? Is it getting the word out there and getting, finding partners to work with? Or, what is the future of Edgewater Wireless? What do you need to improve on?
So, for us, it's a constant process of, broadening our patent portfolio and really building the competitive moat around the company. Going forward, it's about establishing the partnerships that will allow us to accelerate growth and start delivering more products to more people. So partnerships and alliances will help us do that. And really look towards the residential market for us to start making some noise there in the upcoming year or two.
Perfect. So with, of course, with all that, you mentioned patents. I believe I was looking at some of your material on your website. Your spectrum slicing, I believe, was like 24 different patents. Very, very, very well. I guess kind of defined in research. If people wanted to implement this, you have plenty of patents that they could, I guess, kind of pull from. Correct?
That's right, and that's really one of the foundational pieces of the company is the intellectual property portfolio, and that's why it makes sense for us to develop those licensing partnerships to help drive growth and adoption.
Perfect. And so with that being said, I'm looking to see if there's anything that we didn't really touch on. And I think we covered the topics pretty well. Andrew, is there any topic that we did not get into that you wanted to discuss more?
No, I think you've pretty much covered everything I was hoping to talk about today. It's been an excellent session.
Perfect. Yeah, no. And again, this, I think since you were last on to now is a great amount of time for you to come back on the program and, kind of reiterate this for anyone who has not heard about it. And of course, being able to, kind of see what you guys have been up to. I'm glad that the pandemic and, it's actually fun that so many of our, kind of past guests have actually been handling the pandemic pretty darn well, because as tech companies, they are able to kind of work from home, shift everything, and kind of keep things rolling. So I'm glad that the same held true for Edgewater Wireless. So that's great.
Great. Well, thanks very much for having me.
Yep, absolutely. So everyone, we have been talking to Mr. Andrew Scoffel. He is the CEO of Edgewater Wireless. Again, edgewaterwireless.com. If you'd like to learn more there, you can find everything from their white paper, case studies, just read more about it yourself. Although I think this show was a great one to get a good idea of what we're talking about here. And that'll be up over at computeramerica.com. We'll have it in the show notes. So Andrew, I want to thank you again so much for your time and in doing this. So until next time, thank you again.
Thank you.
All right, perfect. So, and now to our guests, we're going to be very, very rude, and we're going to actually end the Zoom call so we can wrap up the recording here. But again, thank you so much, and see you here next time. Bye, everyone. And so here we go. Thank you again. Perfect. Okay, everyone. So we are going to go ahead and do computer and technology news, and that's brought to you by Computer America. We can go ahead and get that started now. Oh no, no, it works. I lied. I panicked too early. By the way, since I'm just on the topic, and Edgewater Wireless, it was a lot of fun, but just because I'm on the topic, Wi-Fi 7 is something that I have actually not talked live on the show about. And these are some of the charts, and this is what the next generation of Wi-Fi is promising. They're hoping that this technology is going to be launched over the next 20 years. And of course, 20 years of Wi-Fi, 20 years looking forward, and they're hoping that over the next 4 years, this is what's going to be the new standard. And by the way, for anyone following the old naming scheme, So 802.11.ax Wi-Fi 6 is what we're currently on, and there's of course 6E, which is a little bit better performance. But Wi-Fi 7 or 802.11be. So AC to BE. Wi-Fi 7 has an ambitious goals that must meet tight requirements to meet our increasing connectivity needs. The IEEE is still has a lot of work ahead of it, and plans to approve and publish the 802.11be amendment by mid-2024. And we expect to see commercial equipment by the same time, along with a certification program by the Wi-Fi Alliance to ensure interoperability. Because it's not just so much that you have Wi-Fi 7 and everything just kind of turns off, but it's also having Wi-Fi 7 and then everything works with Wi-Fi 7, including past standards. Now, with that being said, looking at, kind of the timeline here, and you can see it, within 5 years, this started to 802.11be starts to come into fruition when 802.11ac gets implemented. So as soon as one gets out, the next one gets in, and over the next, so over that 5 years from early 2019 when AC came out or AX came out, you start looking towards the next iteration. So hopefully by May 2024, we start to see some better changes. Now, with that being said, it's not here yet, and there's still a bunch of features that these numbers could definitely change. But as you can see here, this is the chart of what we currently have. By the way, Wi-Fi 6E, which will be implemented this year, is 802.11.ax. Has a max data rate of just under 10 gigs, which I think a lot of people knew that. But Wi-Fi 6E promises to start utilizing this 6 gigahertz band. And that's what Wi-Fi 7 is going to pick up on as well. It will fully implement the 6 gigahertz band as a standard, not just, kind of a tack on, but you are looking at having the traditional 2.4. So everything you have will still work with what you're currently using. The 5 gigahertz, which I think people are just now starting to adopt, although, like I said, there are connectivity issues that just don't work all that well currently. And then the 6 gigahertz is something that they are going to be working on even more. All these will be, this next standard will be using WPA3, even more strict and secure. And I think the best part of this, the channel size is up to 320 megahertz. So a much wider band. A lot more things can utilize this band without congesting it. The modulation, they're mentioning with extensions here, it's 4 times using QAM. And the multi-input, multi-output, and of course the multi-user, multi-input, multi-output, the way that the Wi-Fi 6 currently works is 8x8. So you can have 8 different radios, and of course these are upload and download. And I think that this part here where it says the next generation Wi-Fi 7 is going to be 16 by 16 multi-user, multi-input, multi-output. It does not designate upload and download. So it could have what we were talking about a little bit earlier, where instead of having 8 upload, 8 download, you have 16 by 16, and you could have those be assigned to upload or download. So you have 32 essential, you essentially have 32 pathways that your devices can utilize. And that's definitely going to be appreciated because 4 years, actually I should say 3 years. We're in 2021. 3 years is a long time. And I would not be surprised if the amount of smart IoT devices in people's homes doubled in those next 3 years. That seems completely reasonable to me. Now, with that being said, there's a lot more information here about Wi-Fi 7 and what it plans to do. Things like doubling the max channel size for from Wi-Fi 6, 20% increased throughput, and of course, there's going to be better connectivity, the doubling of spatial streams from 8 to 16, so you can double the network throughput in certain scenarios. Let's see, there's so much here. This is a really good upgrade. This is an amazing upgrade from Wi-Fi 6 to Wi-Fi 7. Unfortunately, this is going to be multiple years in the making if this actually comes to fruition. So I'm hoping it certainly does. Let's go ahead and continue on here, and let's see. Like I said, a lot of the tech stories today are really being dominated by the, I guess, kind of the weather events that are happening throughout the country. Let's see. So I think our next one that we're going to talk about, acting NASA. Okay. Unfortunate. A little update here, and okay. Little update here. Acting NASA chief says that 2024 is no longer a realistic target for a moon landing, which is unfortunate because I think a lot of people want to go back to the moon. Saying that the 2024 lunar landing goal may no longer be a realistic target due to the last 2 years of appropriations, which did not provide enough funding to make 2024 achievable. In light of this, we are reviewing the program for the most efficient path forward. Now, the administration supports the goals of Artemis program, and we are excited about the next steps, he said, and we fully intend to maintain the continuity of purpose for the Artemis program. And by the way, that's what Jurkic said during an interview, that NASA has welcomed the vote of confidence from the current administration. Yep. So of course, there's a lot that there, and I hope that they do it. Let's talk about something else that's this one from Ars Technica as well. Kyle Orland, Steam developer gets banned for very positive review trickery. Very different. So, and by the way, Steam reviews are amazing. That's, much like Amazon and their early value proposition was the review system of Amazon. And of course, it evolved into something much, much more. But reviews matter. And with that being said, go ahead and leave us a review here on Computer America. Thank you so much. But check this one out. Here, and they said that, with that being said, this is a developer got kicked off of Steam just because because of its name. That's just what happened to Emoji Evolution developer Very Positive, which said on Twitter Saturday that its developer account has been banned for review manipulations. Unlike other prominent examples of Steam user review manipulation, Very Positive didn't do anything unduly to skew the reviews of players posted for its games. Instead, Very Positive exploited a vagary of the Steam Store's user interface that the developer or the publisher name is written in the same font, color, and general area as the summary for the game's overall user review summary, which, by the way, goes from overwhelmingly positive, mixed, mostly negative, etc. Thus, it was hard for users to distinguish at a glance that Very Positive developer name was not an accurate summary of the Emoji Evolution actual reviews, which range from mostly positive to mixed. And so, with that being said, Simon Carless was among the first to notice this bit of trickery in his Game Discover Code newsletter on February 8th. Over the next few days, word of Very Positive existence and action spread among gaming news sites, and on February 12th, the developer had been banned from Steam. And with that being said, the coder behind Very Positive said, I knew the reviews have a huge impact on the customer's decision. I noticed that the publisher developer name is located really close to the reviews of the same color, and I decided to use it for my own purposes. So he just straight up said, I did this for manipulation. And he said that make conclusions about information when seeing familiar words and don't spend much time reading all the words. So he seems to have taken the band in stride, promoting memes and jokey polls about the saga on Twitter. And he said, to be honest, the name is the best thing about the whole emoji revolution project, acknowledging the bargain basement simplicity of the game itself, which, by the way, does look really, really slapped together. No offense. But there you go. Now, saying that I've made a really bad game. This is the only thing I'm guilty of. He said in a tweet, if making awful games is not allowed on Steam, why haven't they suspended the CD Projekt Red account? Which is, of course, one would hope, a joke. So there you go. In the end, he tried to exploit a small attention glitch in Steam's Byzantine store system and failed in part because too many people gave it attention. There you go. And he said that going forward, we can't help but think of a UI change on Valve's part might be the more effective than policing individual developer names and fake review summaries. And, yep, well, hopefully they have not caught on to, as someone in the Dr. Spock 11 said in the comments, luckily they haven't caught on to developer overwhelmingly positive yet. So, yeah, again, the guy knew what he was doing, and there's really no excuse for it. So, with that being said, everyone, thank you so much for tuning into the program. Again, thank you to Edgewater Wireless for joining us here on the program today, and of course, ComputerAmerica.com for the show notes, as well as our giveaway. If you'd like to enter to win hundreds of dollars worth of prizes, we thank you so much, and we definitely encourage you to go do that. Everyone, until next time, have a great day. Bye-bye.